Okay, I'm sorry, I'm running out of battery and I'm trying to finish. It's late at night and I don't want to get this posted so you folks can see it. So where were we? We were assuming that P is not isolated in lambda, which means either folks are clustering in and getting close, and it takes them different exit times, in which case we have a sequence of different a sub k's, and all the endpoints of the a sub k's are actually in lambda, so there's a sequence of points in lambda, and so that means that's a contradiction of the isolated thing. So the other possibility is if not that it takes more and more and more every time, that there is a particular choice for k, which we call n, so that if you take the nth iterate, then they are all outside at the same time. Well, ultimately, if you iterate enough, then there's an n, so that if you iterate, then the p will be at 0, and all of its neighbors will be over here negative, because if you're going to ultimately leave, you end up being negative. And so that meant that there's, for that n value, then it's locally a max, because nth iterative f at p is 0, and for all of its neighbors in the neighborhood, it's negative when you iterate. And so that means that's locally a max, which means its derivative is 0, but the chain rule gives us this big product is 0. That means one of the pieces is 0, say one of these values for this number of iterates of f. And so that is just a point in lambda, because p stays in lambda forever. And so the chain rule thing here is reducing it back to our original function f. The derivative of the original function f for this value is 0, and the original function only has one place where the derivative is 0, which is a half. So that ith iterate of p has to be a half. But then that means when you keep iterating, then the I plus first iterate goes outside, and p goes to minus infinity, but p was in lambda. So that's a contradiction. You can't have case 1, and you can't have case 2, and so the assumption about p being not isolated can't be true. So either way you get a contradiction. So p is isolated gave you a contradiction, so p cannot be isolated. So that's what we wanted, that p is not isolated. So we assumed that p was isolated, and what we got in either of those possibilities was that first was an easy contradiction, but then was that we got this more complicated contradiction. If p is isolated, then its neighbors go away, and if its